Good morning, everyone. I am Usman K, Assistant Professor, BITM Ballari. First, I welcome you all to my first video lecture on Module 4. So, the name of the module is Three Dimensional Weaving and Visible Surface Detection. This is name of the fourth module. So, before starting new module, I would like to revise what are the concepts we learned in the previous model. So in the third model, we learned two main concepts like how we can perform clipping against the given object. Like we learned various types of clipping algorithms like point clipping algorithm, line clipping algorithm, and we also learned how we can clip the polygon against the given two-dimensional clipping window. So after discussing various types of clipping algorithm, we also learned how we can perform various operations on a three-dimensional object. Like we learned how to perform translation, rotation, scaling, shearing, and reflections. So these are the various kinds of operations we applied on a given object. So from the module 1 to module 3, we learned two things. First one, I can say that how to create a two-dimensional object as well as how to create a three-dimensional object. So after creating objects, we applied various types of operations on those objects. Next, we applied clipping concepts on those objects. After applying clipping concepts, finally, we displayed those objects on the screen of the monitor using two-dimensional weaving concept. So in the second module, we learned what is two-dimensional weaving and how we can display given image on the screen of the monitor with respect to two-dimensional weaving. So today, I would like to introduce one more concept called three-dimensional weaving. So after discussing three-dimensional weaving, we will see what is visible surface detection and what are the various types of algorithms we are using in visible surface detection topic. Now, I would like to start three-dimensional weaving concept. So in model 2, I said whenever we want to display any two-dimensional object, we need two-dimensional weaving concept. So in case of two-dimensional weaving concept, I said we are performing two basic operations or two basic things. First one, we we are performing modeling. Second, we are performing two-dimensional weaving. So as I said, whenever you want to create any three-dimensional object or two-dimensional object, first we need to specify its position, its position in a two-dimensional Cartesian reference frame. But here we need to learn what is three-dimensional weaving. So in case of three-dimensional weaving also, we need two basic properties or we need two basic concepts. First, we need to perform modeling with respect to three-dimensional object. Next, we need to perform three-dimensional weaving. So as we already learned what is the meaning of modeling. So with respect to three-dimensional object, whenever you want to create any three-dimensional object, you need to specify mathematical description of that particular object. That is called modeling. So the outcome of the modeling is assume that we constructed one three-dimensional object. Next, we need three-dimensional viewing concept. So, what is the meaning of three-dimensional viewing? Means three-dimensional viewing is a process of displaying three-dimensional object in a space on the two-dimensional display device. This process is called three-dimensional viewing. So, in case of three-dimensional viewing, our aim is we want to represent any object in this space having three dimensions. Like we have x dimension, y and z. These are the three dimensions are there for every object that is exist in the world or every object that is exist in the space. Now we want to represent that three-dimensional object in a space into two-dimensional screen. So displaying three-dimensional object in a two-dimensional screen is called three-dimensional viewing. So whenever we want to use three-dimensional viewing, definitely we should know that why we need three-dimensional viewing. So before explaining why we need three-dimensional viewing, I would like to revise why we need two-dimensional viewing. So when we are using two-dimensional viewing, we can view or we can display only one face of the object on the screen. Only one face means I can view only two dimensions like x and y dimension of every object in case of two-dimensional viewing. So in case of two-dimensional viewing, we can able to view only front end of the object. But in case of three-dimensional viewing, we can view for the given object either front end of the object or side ends of the object or top end of the object. Means we can view the three-dimensional object in case of three-dimensional viewing either front side or top side or side end of the given polygon or displayed polygon. So this is the use of using three-dimensional viewing. So these are the two concepts I would like to explain with respect to this slide. So before going to second slide, just I would like to tell what is three-dimensional viewing. Then I will proceed to next slide. Representing n dimension object into n minus 1 dimension screen is called three-dimensional viewing. So every object in the space having three-dimensional, I want to represent the three-dimensional object in a two-dimensional display devices. This process is called three-dimensional viewing. So this three-dimensional viewing is almost same as taking a picture by using real camera. So as you can see this slide, I displayed this slide here. In this slide, there is two images are there. Just I would like to discuss why we need three-dimensional viewing. So in this slide, first I want to explain right side of the image. In case of right side of the image, I written one question: how to take a picture by camera. So in case of real camera, how we are taking any picture. In the same way, we are creating or we are constructing three-dimensional image or scene in a computer graphics using three-dimensional viewing. So what I would like to conclude here means whatever the concept we are using to capture any image using real camera, same concept we are using in computer graphics to construct computer animated images or two-dimensional image or three-dimensional image we would like to display on the screen of the monitor. So this is our aim of this particular topic. So let's move to next slide. Let's move to next slide. First topic is, in case of three-dimensional viewing, is called three-dimensional viewing concepts. Means whenever we want to display any three-dimensional object on the two-dimensional screen, there are few basic concepts we supposed to learn. Now, before explaining what are the 3D three-dimensional viewing concept, I would like to give an analogy where that analogy is almost same as our three-dimensional viewing concept. So here I written one sentence clearly. The steps for computer generation of a view of 3D scene are analogous to the process of taking photograph by a camera. So as I already said in the previous slide, creating computer images are creating two-dimensional images or three-dimensional images in computer graphics. It is similar to taking photographs by using real camera. So as you can see that by using real camera, I would like to capture one image that is present in the space. So here we have an object and here we have a real camera. So whenever you capture the image by using real camera, that captured image is displayed on the film of the camera, or you can see that the captured image is displayed on the screen of the camera, or I can say that on the film of the camera. So whatever the process we are using to capture the image by using real camera, same concept we will use in synthetic camera in our OpenGL to display captured image on the screen of the monitor. Means capturing image is nothing but we need to perform modeling, means we need to create the image. Once the image has been created, we need to display that image on the screen of the monitor in case of synthetic camera or in case of OpenGL. But in case of real camera, when you capture the image, that captured image is displayed on the film of the camera. So displaying captured image on the film of the camera is nothing but real camera. Using real camera, we are generating images. But in case of computer graphics, we are using three-dimensional viewing concept to display the captured image or to display the created image on the screen of the monitor. In case of computer graphics, we are displaying three-dimensional object on the screen of the two-dimensional screen of the monitor. It is same as in case of real camera, we are displaying three-dimensional object that is there in this space on a two-dimensional photograph. The process is same here. Process is same, but there is two types of camera we are using. We are using synthetic camera in case of OpenGL, and in case of reality, we are using real camera. So first we would like to discuss how to capture image by using real camera. Then we will go to how we can use computer graphics concept called three-dimensional viewing to display the object on the screen of the monitor. So if you want to capture any image, by using real camera, we need to specify three things. Right? So whenever you want to take a snapshot, we need to specify three things in case of real camera. First, what we need to do means we need to position the camera at a particular point in a space, and then we need to decide camera orientation. After specifying position of the camera and after specifying appropriate orientation, finally when we snap the shutter, the scene is cropped to the size of the window of the camera and the light from the visible surfaces is projected into the camera film. Then we can say that we created one snapshot or one image and we displayed on the film of the camera by using real camera. So I can say that whenever you want to capture any image using real camera, first you need to decide viewing position. Viewing position is the first requirement to capture any object by using real camera. So as you can see this diagram, I would like to capture this house that is exist in the real world or in the space. So to capture this house, assume that I kept camera here. I need to decide the particular point for the camera so that I can capture this particular image. So I decided what is the position of this particular camera so that I can capture this house or this image that is exist in this space. First requirement, set the viewing position. Second requirement is I need to adjust the orientation of the camera. Adjust the orientation of the camera is nothing but I need to adjust the lens of the camera. I need to adjust lens of the camera so that I can capture the entire house. Entire house. So this is my second requirement. Means camera orientation is nothing but second orientation. Right? Orientation means rotating camera either clockwise or anti-clockwise so that I can capture that complete house as possible as with respect to camera window, right? Next, I need to decide size of the clipping window. I need to specify size of the clipping window. Means I need to do the movement in a such a way that I can capture the complete image. Means I need to specify the window. So in front of that camera we have a window. So I need to set that window in a such a way that I can capture maximum size of that particular image of that particular house that is exist in the space. So these are the three requirements whenever we are creating any photograph using real camera. So same concept we are using in three-dimensional viewing to display three-dimensional object on a two-dimensional screen. So again I'll move to next slide. As you can see that I am comparing how we can create the image by using real camera and how we can create the image in computer by using synthetic camera. So whenever you want to capture any image by using real camera, first we need to adjust the camera stand. That camera stand is called tripod here. Tripod means there are the three legs are there. I need to adjust the camera stand first. In case of computer graphics, I can say that I need to adjust the viewing here. I need to adjust the viewing, that is positioning the viewing volume in the world means here I need to adjust our viewing concept here, position of the viewing volume. I said clearly, in case of three-dimensional viewing, our clipping window is like a cube where six different two-dimensional clipping planes are there. So first I need to adjust like this. Next, after adjusting camera stand, next I need to adjust camera position in a such a way that I can capture the image. I need to capture this image. I mean, assume that here, see the most point. I want to capture this spot. I want to capture this spot. If I want to capture this spot, I need to adjust the camera position in a such a way that I can capture the entire pot. Entire pot. So here I am setting camera position like that, like that. In case of synthetic camera, I need to perform modeling here. I need to perform modeling. Here, if I want to perform modeling, as we know that in case of computer graphics, modeling means defining mathematical description of the particular object. So this part is there in the space, in a space that is called world coordinate. This object is there in the space. So I need to describe what are the mathematical properties of this particular object in case of synthetic camera or in case of computer graphics, right? So in case of three-dimensional viewing, whatever the object that is there in the three-dimensional space, every object having width and height and depth. But in case of two-dimensional viewing, depth is missing. Depth is missing because I can view only x coordinate and y coordinate, only two dimensions. I cannot able to view third coordinate called z. But in case of three-dimensional viewing, I need to represent every object in three dimensions like x and y and z. That is called every object in the space is represented with respect to width, with respect to height, with respect to depth. When depth is comes into a picture, then I need to take clipping volume so that every object I can capture front end as well as top end as well as bottom sides of the particular object. So here we are performing modeling in case of synthetic camera. In case of real camera also we are performing model. I can say that model means adjust the camera position in a such a way that I can capture this complete part. That is nothing but modeling with respect to real camera. I'll go to third row. I'll go to third row. I'll go to third row. So once you set the camera position as well as orientation, assume that we set the camera position as well as orientation, means I adjusted that camera so that I can capture the entire part. Next I need to adjust the lens in case of real camera. So adjusting lens of the real camera is nothing but I want to capture that entire part image. So adjusting the lens here in case of real camera. In case of synthetic camera, we need to specify the projections. We need to specify the projections. So we are using new concept called projections. So that projections defines how to project three-dimensional object that is created with the help of modeling on the screen of the monitor. We know that screen of the monitor is nothing but always it is a two-dimensional. So whatever the object you created, it is nothing but three-dimensional. Now by using projections, we want to project three-dimensional object on a two-dimensional screen. This process is called projections, right? So once you perform projections, that image has to be displayed on this screen. So in case of real camera, after capturing image, that image is displayed on the film with the help of lens, right? That image is captured and that captured image is displayed on the film of the camera with the help of light source, with the help of light source, right? And whatever the image you captured, you need to display that image on the photograph. Means here our aim is I want to take one photograph, one nice photo I would like to take, and I want to create one photograph. Whatever the image you captured by using real camera, now it is already there in the film, camera film. Now I want to project that image from camera film to photograph. Means I would like to print. I would like to print. So if you print that image, then your photograph is ready. Your photograph is ready. So whatever the image that is present inside the camera film, that is projected on the photograph. So I can say that that part is one three-dimensional object it is exist in the space. I translated that three-dimensional object that is present in the space to photograph. So I can say that our photograph is nothing but it is a two-dimensional paper or one two-dimensional one sheet. On the two-dimensional sheet, I projected I projected one three-dimensional image. It was there in the camera film through the printer. So through the printer, as per my example, but the technology is now the technology is different. As soon as you capture the image, immediately you'll get that photograph, right? So displaying that photograph is nothing but three-dimensional viewing in case of real camera. Same concept we would like to apply in case of computer graphics also. In case of computer graphics, now what I am telling means, here with respect to synthetic camera, first step is we need modeling. So modeling defines mathematical description or position of the object that is present in the space. So once you complete modeling, next you need one more concept called projections. So projections helps us to transfer the three-dimensional object position present in the frame buffer to the screen of the monitor. So we are using projections. Projection is an intermediate step to transfer the created object from the frame buffer to screen of the monitor. But in case of third step is after projection, I need third step is called three-dimensional viewing. So three-dimensional viewing is a process of displaying three-dimensional object on a two-dimensional screen. So if you see this example, please you see the right side, uh, fourth row, right side fourth row. In case of synthetic camera, if I want to display this part on the screen, I said here viewport. I said viewport means whatever the image you created with the help of modeling, and whatever the image you would like to transfer through the projection on the screen, you need to first to project that screen. You need to project that image on the viewport. As we learned already, what is viewport like this? Viewport is a rectangular display area. It decides where you would like to display image on the screen of the monitor. So with the help of projection, we projected that image on a viewport. Whatever the image description you projected on the viewport, we need to translate the content of the viewport to screen. That is called viewport to screen coordinate mapping. So once you translate the content of the viewport information to the screen, then finally you can view three-dimensional object on a two-dimensional screen. So these are the concepts we need in case of three-dimensional viewing. So I hope you understood what is the similarities between real camera and synthetic camera. So I would like to conclude this concept. Whatever the concepts we are using in real camera to capture the image and to display the captured image on the photograph, same concept we are using in synthetic camera or we are using in computer graphics to display three-dimensional object that is created with the help of modeling on the screen of the monitor with the help of three-dimensional viewing concept. So if you see this next slide here, same thing I revised here. What are the concept we are performing like this, right? So what are the, it is similar to previous slide only. So first what we did, first whenever you want to capture image or whenever you want to create image in computer graphics, choose the position of the camera and pointing it at the scene. This process is called weaving transformations. Means I'm explaining what are the next concepts we need to learn with respect to this slide. Means whenever you want to create the camera, whenever you want to create the image, three-dimensional image, or whenever you want to capture image using real camera, what is our first step? Means choose the position of the camera and pointing it at the scene. This process in computer graphics is called weaving transformations. So once you set the position of the camera towards the object, next arranging the scene means object, arranging the object to be photographed into the desired composition. This process is called modeling transformations. This process is called modeling transformations in computer graphics with respect to synthetic camera. Third is third is once you specify position of the camera towards the object, after arranging the scene or after arranging that orientation of the camera, next choosing a camera lens or adjusting the zoom. Means generally when we want to capture the image, we will perform zoom in and zoom out. When you want to capture that image in a larger size, we will move that lens near to that particular object. Means we are adjusting that lens. If you want to capture a image of very smaller size, then you will perform zoom out. You will perform zoom out means again you are adjusting the lens. That adjusting the lens is nothing but projection transformation in computer graphics. So adjusting the lens is nothing but projection transformation in case of computer graphics. Next, after adjusting the camera lens, next we need to specify or we need to determine how large you want to the final photograph to be. Means whether you want larger size of the photograph or whether you want very small size of that particular object on the photograph. So this this is nothing but viewport transformations with respect to computer graphics. Means the size of the object on the screen of the monitor, it depends on the size of the viewport. Size of the viewport, we already discussed this concept in case of model 2. If size of the viewport is larger than the size of the clipping window, we will get larger image on this screen of the monitor compared to the object that is present in the clipping window. Next case is if you want smaller size of the object on the screen of the monitor, then size of the viewport should be smaller than the size of the clipping window. Then you can display a image of smaller size compared to the image size that is present inside the clipping window. So these all these things we discussed in the model 2. Now whatever the steps I written in this slide with respect to the textbook, I copied from the Red Book textbook. I am comparing, here we are comparing what are the difference between or how we can use the terms with respect to computer graphics and with respect to real camera, right? So these are the types of transformations we need when we want to translate any image that is present in the space to the two-dimensional screen of the monitor. Next, you see that what are the terms we are using with respect to synthetic camera compared to the real camera. So in case of real camera, captured image is displayed on the camera film. In case of real camera, please you see the slide or mouse pointer. In case of synthetic camera, I am telling in computer graphics or I am telling in OpenGL, same camera film, we will call it as a projection plane, or I can say that it is called virtual plane. Means In case of three-dimensional viewing, projected image is displayed on the projection plane. So this projection plane is called virtual plane in case of synthetic camera. But in case of real camera, this is called camera film. What I would like to conclude here means camera film, it is similar to projection plane in synthetic camera. And in case of real camera, when we want to translate that object present in the space to camera film, we need rays. With the help of these rays only, the reflected rays, when a light of source is reflected on the object, those reflected rays enters inside the camera through the lens, and those rays helps to project the image on the camera film. The same rays concept we will use in case of synthetic camera, and those rays are called projection lines or projectors. So in case of whenever we are discussing projection lines, you need to remember projection lines is nothing but rays in real camera. In real camera. So third one is in case of real camera, we will use lens to adjust so that I can capture maximum part of that particular scene. Maximum part of that particular scene means I am adjusting that. I am performing zoom in and zoom out. Or I can say that adjusting camera is nothing but we will try our level best to capture the, or we want to cover the entire area of that particular object. But it depends on the our lens of the camera. But in case of synthetic camera, we will use clipping window, or we will not tell clipping window. Generally, we will tell clipping window. We should tell clipping volume. So that clipping volume decides what is the maximum size of that particular object I can able to capture. So our clipping volume having 6 different planes, or I can say that our clipping window contains 6 two-dimensional clipping window that defines width of the object, means what is the maximum width of the object I can able to capture, and what is the maximum height of the object I can able to capture, and what is the maximum depth of that particular object I can able to capture. Means when you want to capture the three-dimensional object, then we need clipping volume in case of synthetic camera. But in case of real camera, lens decides what is the maximum area of that particular object has been captured. Next, we need to decide field of view, or I can say that angle of view. Angle of view decides what is the area we are covering with respect to that image. But in case of synthetic camera, how to adjust field of view means field of view can be specified, or what is the field of view in case of synthetic camera means it is a distance between camera and projection plane. It is a distance between camera and projection plane. What is projection plane? Already we learned. Projection plane is nothing but camera film. Now the distance between camera and projection plane is nothing but field of view. That is how to define distance between camera and projection plane in synthetic camera means we need to decide what is the near distance and far distance with respect to camera and projection plane. So when you specify near distance and far distance, then only we will get 6 different two-dimensional clipping planes in case of synthetic camera. In case of real camera, I am explaining fifth point. In case of real camera, we need to specify what is the distance between object and camera. We need to specify same thing in case of synthetic camera also. That is the first parameter. Second parameter, you need to specify the position of the camera also. Because if you want to capture any image, you need to specify where I can locate the camera or what is the position of the camera so that I can capture that particular image. The same concept I need in case of synthetic camera also, means I need to define what is the position of the your synthetic camera in OpenGL so that I can display three-dimensional captured image on the two-dimensional screen. So the position of the camera is also very important. Third parameter with respect to real camera is direction. Direction is also very important whenever you want to capture the particular image. Means direction specifies I need to adjust, I need to rotate the camera either clockwise direction or anti-clockwise direction, or I need to set the camera towards the object direction, towards the object direction. So direction in case of real camera. Same direction I need to specify with respect to synthetic camera. This is the direction of the camera towards the object. Next, we need to specify orientation. Orientation I need to specify in case of synthetic camera also. So I would like to conclude this slide. Whenever you want to create three-dimensional object in computer graphics, you need to specify distance between camera to projection plane or distance between camera to the object. Second, you need to specify what is the position of the camera so that I can capture that image or so that I can display three-dimensional object on the screen of the monitor. Next, I need to specify direction. Next, I need to specify orientation of the synthetic camera. So, these are the four properties or these are the four parameters I need to consider whenever we are displaying three-dimensional synthetic image on the screen of the monitor. So next we'll move to next topic, how we can start creating three-dimensional object and how we can project created three-dimensional object on the screen of the monitor using three-dimensional viewing pipeline. So I already discussed this topic in module 2. The topic name was two-dimensional viewing pipeline. So when you want to create any three-dimensional object, what is the first step we learned means first we need to perform modeling. So to perform modeling, I said we need modeling coordinates. So we need to map modeling coordinate to screen coordinates so that I can display created three-dimensional synthetic object on the screen of the monitor. So to perform the process called mapping modeling coordinate to screen coordinate, we supposed to perform series of transformations or sequence of transformations, and those transformations we already learned like modeling transformations, viewing transformations, projection transformations, normalization transformations. Finally, normalization transformations will map to the viewport transformations. Then finally, viewport transformation will display the image on the screen by performing screen coordinates mapping. So here I written one sentence. That sentence says that what is the aim of three-dimensional viewing pipeline? The general processing steps for modeling and converting a world coordinate description of a scene to device coordinates means here we are performing displaying three-dimensional object on the screen of the monitor. Not only we are displaying, here we are discussing how to create three-dimensional object by specifying its position in the world coordinate or in the modeling coordinate, and finally we want to map this to the device coordinate. So as we already discussed, so I don't want to discuss once again here in depth, but I would like to say one thing here with respect to three-dimensional viewing. In case of two-dimensional viewing, projection transformation will not comes into a picture. But in case of three-dimensional viewing, we have projection transformations. So because of this, I would like to explain three-dimensional viewing pipeline concept once again. So we'll move to next slide. So first, what we need to do is, first we need to perform modeling. That is the first step is construct the shape of the individual objects in a scene within the modeling coordinates. So we already learned this, how to perform modeling, right? So once you perform or once you represent shape of the individual object by specifying by taking individual Cartesian reference frame and place those objects into appropriate positions within the world coordinate or within the scene with respect to world coordinate. So this is the first step. As you can see that yellow color represents, see the mouse pointer. So first we are mapping modeling coordinate to world coordinate. With respect to modeling coordinate, assume that our image contains multiple objects. So we represented multiple objects by using multiple Cartesian reference frame, and we integrated those multiple reference frame into one Cartesian reference frame, so that I can integrate all the individual objects of the image into one complete image in one Cartesian reference frame. That process is called world coordinates. World coordinates. So we represented modeling coordinates into world coordinates by using modeling transformations. Next, we need to perform weaving transformations. I'll go to next slide. If I want to perform weaving transformation, see that I written step 2 clearly. World coordinate positions are converted into weaving coordinates. We learned this also, how to map world coordinate to weaving coordinate in two-dimensional weaving. Now we need mapping world coordinate to weaving coordinate in case of three-dimensional weaving pipeline also. So once you map world coordinate to weaving coordinate, step 3 says that convert the weaving coordinate description of the image to coordinate position on the projection plane. See that this step was not there in case of two-dimensional weaving. In case of two-dimensional weaving. So what we did means we mapped weaving coordinate directly to the normalization coordinate. Next normalization coordinate to viewport coordinates, and next we mapped viewport coordinates to screen coordinates. Projection mapping was missing in case of two-dimensional weaving, but in case of three-dimensional weaving, here I written third point clearly. Convert means map the weaving coordinate description of the object to coordinate position on the projection plane. Means here we need projection transformations. I written clearly here. See the yellow color. Map weaving coordinate to projection coordinate with the help of projection transformations. This is step 3. Step 4 is we need to map positions on the projection plane. Will then map to normalization coordinate and to the output device. Then you see that here I written two yellow colors here. Means I highlighted. I am performing two operations here. Two operations here. First, what is the first operation? We are mapping projection coordinate to normalization coordinate with the help of normalization transformations as well as clipping. Why I written clipping here means whatever the part of the three-dimensional object that lies outside the normalization square. Now, it is not square here. Normalization cube. That part of the object has to be clipped out or it has to be cropped. And whichever the part of the object that lies inside the normalization cube, only that part of the object position has to be mapped to viewport, that is called normalization. So once you perform normalization, as I said in the previous slide, that position of the object or the coordinate positions of the object will become device independent. So when it becomes device independent, whatever the object you created here, it can be displayed irrespective of display devices. Irrespective of display devices means that object can be displayed either on the desktop screen or monitor screen, sorry, desktop screen or laptop screen or tab screen or mobile screen, because it once it becomes independent of the display device, you can display in any type of display devices. That is the purpose of performing normalization lines. So next we need to map normalization coordinate to device coordinates, the normalization coordinate to viewport coordinates. Then viewport coordinate we need to map to our device coordinate or screen coordinates. So once you map your normalization coordinate to viewport coordinates and viewport coordinate to device coordinates, then whatever the image you created, that can be displayed on the screen of the monitor. So these are the series of transformations we are supposed to perform in case of three-dimensional viewing. So I would like to repeat here, with respect to three-dimensional viewing, we are performing modeling transformations. Next we are performing viewing transformations. Next to projection transformations, normalization transformations. Next to viewport transformations. After performing these 5 types of transformations, whatever the position of the object you specified in your OpenGL program, that object position is translated in the form of pixels, and finally that image has been displayed on the screen of the monitor. So these are the sequence of transformations we supposed to perform in case of three-dimensional viewing. So before concluding this topic, I would like to tell one more thing. Here we are using various types of windows. First type of window, as we know that clipping window, but I said don't tell clipping window here, tell clipping volume, because our clipping volume is like a cube, so that I can clip top end of the object if it lies outside the clipping window or clipping volume, or either sides of the object has to be clipped out when object is lies outside of the clipping value, and I need to crop the front end of the object if the front end of the object lies outside of the clipping volume. So in case of clipping volume, we have 6 two-dimensional clipping planes. This is nothing but I can say that I have a clipping window. Next, one more type of window we have, that is called normalization window. Normalization window is also like a cube only, Next we have one more type of window called viewport is also like a cube only, everything is in the form of cube here. Please you remember, when you want to display three-dimensional object on the screen of the monitor, all the windows shape should be like a cube. So these are the things I would like to say with respect to this particular topic. So today I introduced three-dimensional viewing. I said capturing any image using real camera. It is similar to constructing synthetic images in computer graphics. So in computer graphics, we are using three-dimensional viewing concept. So this process is similar to capturing image using real camera. This is the first thing I discussed. Then I displayed one slide. That slide indicates what are the terms we are using in computer graphics and how these terms are similar to our real camera components. So this is also I discussed. Next, I discussed how we can map modeling coordinates of the three-dimensional object to the screen coordinates or two-dimensional screen coordinates. To perform this mapping, I need to perform series of transformations. Next, I introduced one more new concept here called projections. So these are the requirement of this particular model. So in the next video lecture, I would like to discuss how we can map viewing coordinate, world coordinate to viewing coordinate, and how we can map viewing coordinate to screen coordinate so that we can display or we can view three-dimensional object on the two-dimensional screen. Thank you.